This is part 2 of the introduction to spectral analysis in TF32. We last talked about how to make measurements in the spectral display. And this particular section, I'm just going to add and discuss a few additional features of this. There's a number of different display types that you can use in this, and I'm not going to cover them all, but I am going to introduce a couple that are going to be of relevance to you as you're working your way through the speech science course. Um, as we've discussed in class, that you can have a amplitude spectrum like this, or you can also have what we've called a spectrum envelope, which is really a more of a broad outline of uh, the overall shape of the spectrum. And you can actually plot something like that in the spectrum window. It's not exactly a spectrum envelope, but it is very similar. It's something called a plot derived from something called linear prediction coding. And what it does is it is an analytical technique that gives you something that is very similar to a spectrum envelope. So when you go over to the right hand side here to the options, if you want to just look at a straight up amplitude spectrum, this H box is selected. If you want to look at something that's more akin to a spectrum envelope, you can click on this LP. And as you can see, what we now have is we don't see the fine grain analysis, we don't see individual harmonics, but we see it as a general outline of the overall, where the frequencies, where the amplitude is at its highest. And so it's a coarser but more representative of the overall shape of the spectrum. Now, if you want to, we click back and look at the original one, the amplitude spectrum. We have another option down here if you want to look at both of them at the same time. There's something down here with the MEM button, which is a memory, and it allows us to take a quick snapshot of this particular plot, so that then when we introduce the second view, the linear prediction coding view, the LPC, you can see that both of them. And as you can tell here, looking at this, this does a pretty good job of giving you a sense of what the spectrum envelope looks like. Now, if you want to get rid of the portion of the plot that's in memory, you can just click the CLR, means clear, and it goes away. And we also have a button over here called copy, and that button is responsible for copying the image in the amplitude spectrum pane to the clipboard, so you can paste it into any other programs, MS Word, if you're putting together a little presentation on a particular sample. It's quite handy to have. Now let's click back so that we're looking at the amplitude spectrum again. Another useful display is something called the long-term average spectrum display. And as you recall, an amplitude spectrum is really a slice in a very narrow time window. It's a little slice over a very small window. And so we're getting kind of a snapshot of what the frequency composition of that sound is at that particular point. And as with many sounds, speech often has, the spectrum composition is varying in a dynamic way. And so from moment to moment, the spectrum actually changes. We can actually, and as a result, we may be more interested in not so much what's happening at a single moment in time, but what is happening over the course of an entire longer period of, for example, speech segments. And the long-term average spectrum allows us to view where the prominent energy is over a fairly large time domain. It can be really as large as you'd like. To generate such a display, you can use your cursors in the sound pressure waveform to encapsulate the portion of the signal that you would like to perform the long-term average spectrum on. And in this case, I'm going to just put it around this entire portion of phonated speech. And you can click on the LTA, which is the long-term average option here. And when you do, you'll see that you still have a spectral display, but it looks quite different than the instantaneous amplitude spectrum that we've seen earlier. What's happening here is um, when you make this choice, the TF32 tool will take successive slices all the way through this entire epoch and basically lay them all on top of one another so that you end up with a whole series of amplitude spectra all overlaid on each other. And then what happens is that it takes average values at each frequency. And so what we see here is this long-term average spectrum is really the mean value at each frequency and mean amplitude at each frequency over the entire course of the um, signal here. And as you can see, when you do that, you lose some of uh, you don't see the harmonics as clearly because there's some smearing that goes on, and not all, since the harmonics are moving around, it ends up causing you don't see distinct harmonics, but you do see where the energy tends to be lying within the speech sample itself. So the long-term average spectrum is often used to give you more of an overall representation of where the energy lies in a segment of speech. And that's basically all I wanted to cover in this particular tutorial. I think this is enough to get you through your homework activities and any other activities you may want to do that involves doing a spectral analysis of any of the speech samples that are on your study disk. I'm just going to click back here. If you want to then leave the spectral display, you just simply go to View and uncheck it, and you're back to where you were. I hope you found this helpful.